On the shark bite, which ones do we want to see, do, go over, have questions about? So I think that's about all of them. So I saw 1, 2, 3, 4, and 5. Some of these can be done on decimals, some cannot. So for number 1, we're going to check it in decimals, but in order to do it, you have to remember how to distribute. Take the first term, multiply it to the first term and the second. 6x times negative 2x would give us what? Negative 12x. The exponents will change to what? Squared. And then 6x times 3, so positive 18x. Negative 5 times negative 2x, so positive 10x. And negative 5 times positive 3, so negative 15. And then combine my terms. So negative 12x squared plus 28x plus 15 should be your final answer there. I'm sorry, minus 15. If you put in the original and put in this answer, they should match up. So there's your original. And then here is your answer. It overlaps that. So that does match, so that is the correct answer for that. The second one, you put in the original, solve it, and then add in sliders. Make sure you capitalize the letters. Change the values. Your answer that you should have gotten was negative 4x minus 3y. If you did not get that, double check your work. You may have forgotten a negative or positive somewhere or incorrectly added. These numbers match, that's how we know that is that answer. Number 3, the points that are not solutions were 0, 3, and 5, 1. 0, 3 falls on the dashed line, so that would not work. And then 5, 1 does not fall in the shaded area. Questions on those 3? Four and 5 can both be done in decimals. 4 can be done algebraically, but if you have your decimals tools, you don't have to do it that way. So if you plot the point that it was given, and then type in your y equals mx plus b and add sliders. What was this? Negative 3 over 2. So if you put in the point, put in your y equals mx plus b, type in your slope, and then move your y-intercepted so it goes through that point. Should be at 5. Exactly 5. So that means the equation of that line was y equals negative 3 over 2x plus 5. No, yeah, that's fine. So anytime you see on the SLL and practicing something that says write the equation of the line, you should be trying to do this. Then for the last one, your graph should look similar to this. Slope of 2, y-intercept of negative 1, solid line shaded below. Questions on either of those? From the back, go ahead and pass up your answer sheets towards the front, and then I'll collect them from the front table. names are you guys going back today? Kelly and Richard. Do you guys bring yours over here? Did you guys all pass yours out? Are you trying? Alright, we won't have much time for practice, at least start this. You do have notes on your desk. Find the page that looks like this, though. This will look somewhat familiar from when we were doing exponent rules and doing polynomial division. Except before we were dividing monomials by monomials, a single term by a single term. And now we're dividing polynomials by monomials, multiple terms by one term. There are two different ways to go about doing this. I'll show you both, and then you can choose which one you like better. So for the first one, you could do this as a splitting method. Whatever it's dividing, split it so it's dividing both separately. And then simplify. What would this be? You could say out loud. 2t plus 3. And that would be your answer. The other way we could go about doing this is using the factoring we were just learning. What is the GCF of these two? 4. Divided that out, what would be left? What would 8t divided by 4 and 12 divided by 4 would be? It would be that same thing. The format is just going to look weird because we factored it out, but it's still being divided. But then we can cancel out the 4s. So you can either do it by the splitting method or you can do it by the factoring method. It should work out the same. Questions on that before we do one more and then it'll be time for lunch. Okay. For number 2, if we were to split it, what would this become? T minus 9. If we were to factor it, what do they have in common? T. And usually whatever's in the denominator is going to be what they have in common. The t's would cancel, leaving that t somewhere. So on the problems we do when we come back, we'll choose whether we split or factor. Sure. Number 3, do we want to do the splitting method or the factoring method? Splitting. Okay, so 15t squared divided by 5t plus 20t divided by 5t. What would be left? If you want to go back and do it the factoring
way, you're more than welcome to. Or if we switch in the future and do factoring way and you want to do it splitting way, that's fine. Do we have any questions on that? Matthew, close your laptop. We're going to skip to 5. Splitting method or factoring method? Splitting, okay.
8a squared b over ab plus 3ab squared over ab.
Subtract your exponents. What would be left? We can say it out loud.
8 plus a plus 3.
Skip down to 7. Splitting or factoring? Okay. 8 will do factoring, just so you can see it one more time. So what would that first one be? Plus. What would the second one be? What did you say?
Not to the third.
But to the fourth. You were close. Questions on that? Eight we're going to do as the factoring method. What do each of these have in common? 9a to the third b. And what would be left if we divided that from each one? What would be left there? B to what power? B to the fourth, the first one. And then 5a squared. To what power? Plus 1. So then those are the same, so they would cancel. So 2a to the fourth, b to the fourth, plus 5a squared, b squared, plus 1 is that final answer. So I'm going to show you an example. All of these worked out very nicely. You got nice answers. I'm going to show you an example where you won't get a nice answer. So somewhere where you have space, I want you to write this down. And then we're going to do it both ways just so you see what happens. But with these type of problems, and you won't know it until you go to do it, it's better to do the splitting method. You'll see why here in a second. So some of these are going to work out nicely and some of them are not. And when you go to subtract the exponents, you're going to end up with negative exponents, which means you're going to have fractions. What would this first one be? Y squared. Everything would cancel except for the y's, and then you would subtract the exponents. For this middle one, you'd have 9 divided by 3, which would give us 3. Because the exponents in the numerator are 1, when you go to subtract them, you end up with negative. So negative x to the negative 1 and y to the negative 2. So you could flip those as you start working them. I'm going to do that in a moment. What would the last one be based on what we did for the middle? Exactly. Just x. It would just be 1. Y. So then anything with a negative exponent, we can't leave it like that, so we have to make it into a fraction. So the first term would stay the same, the 3 would stay the same, but both of these would get put in the denominator, x to the positive 1, y to the positive 2. And then for the last term, 8 and x would stay in the numerator, and y would be in the denominator. So that is the answer. It just is not as nice as the other ones. So that's why separating it, splitting it, might be better. Factoring can be done, but it'll get messy. So I'm going to show you what that looks like, and then you choose. I'm going to rewrite this. Actually, I'll just do it up here. Okay. What do these have in common? I heard 3 and x. And any y's? Yes. How many? So 3xy. If we divide that out of these 3, what's left? What would be left? And then it will still be all over 3x squared y to the third. So this is how you would know that this might not be the best method to do this, because these don't match exactly. You're still going to do it the same way, but then it becomes a little bit complicated. I'm going to rewrite this. 3xy over 3x squared y to the third. If we were to simplify just this piece, what would that become? Subtract your exponents, you're going to end up with negative ones. So then this would become 1 over xy squared. And you would have to distribute it back. So we have xy to the fourth over xy squared minus 3 over xy squared plus 8x squared y over xy squared. And then you would have to simplify. So this is why factoring might not be the best way to go for these. First one would get us our y squared. Second one is our middle term, as we already had it. There's nothing that can be simplified. Second one, the x's and the y's would both simplify. So you would get the same thing. The factoring just has more steps. Questions on that? So just be patient and take your time when you get two problems like that. Find this page. This is the last thing we're going to talk about today. So we were doing polynomial division by a monomial. Now we're doing polynomial division by a binomial. And there's a specific way we have to go about doing these. We're going to use all the factoring methods we just learned to solve this. So we have to factor the numerator, and then some of the terms will cancel. This is a basic trinomial where a equals. Anyone remember what the rule is for that type of trinomial? And you will need to know the difference between these. But if a equals 1, you're looking for two numbers that multiply to be 6 and add to be 5. What two numbers would work? I heard and 2. What was the other one? 3 and 2. With your basic trinomials, you can go straight into your factors. X plus 3, x plus 2. And then look and see if you have any like factors and cancel them out. So the x plus 3s are the same. So this would be left with just x plus 2. And that would be your answer. Do you have any questions on that before we continue? We're going to do one of each type of factoring on this. So we're going to skip to 3. This is a trinomial. Let's see, does this have a GCF? Something they each have in common. 2, yes. So if we factor out the 2, what's left? Divide each of the ones in the numerator by 2. What's left? Then the inside piece looks the same as the one we just did. So you're looking for two numbers that multiply to be 1, but add or subtract to be negative 2. What two numbers would work? What numbers multiply to be 1? 1 and itself. But how could we make them add or subtract to be negative 2? Negative 1 and negative 1. So keep bringing that 2 down, but then we have x minus 1 and x minus 1. This would only cancel with one of them, not both. So you can leave your answer as 2 times x minus 1, or you can distribute it. Either or. Questions on that one? Let's try 4. Does that one have a GCF? No. Anyone remember the next step if it doesn't have a GCF and it's not a basic trinomial like those were? Multiply 6 and 5. So we're looking for 2 numbers that multiply to be 30 and add to be 13. You were thinking if one was negative. So 2 numbers that multiply to be 30 but add to be 13. And the 3 work. What's the next step? What do we do after we find those 2? Anyone remember? Yeah. So take the 10 and 3 and replace the 13. So 6x squared plus 10x plus 3x plus 5. Now we have 4 terms, and we can use our grouping. How do we do that? Put it down the middle, and then after it's split down the middle, what does that help us do? Or what do we do? Kind of. We do factor both sides, but by looking for the GCF of both sides. So what would that be for this side? 2x. What would be left? 3x plus 5. What could we divide out of those 2? 1. So if nothing else, you can always divide out of 1. And then rewrite your factors. So we have 2x plus 1 and 3x plus 5. So what would our final answer be? 3x plus 5. So the 2x plus 1 would cancel. Questions on that? So if you're not good with that factoring process, you'll need to go back and practice. Make sure you are good with that because you'll have to know how to factor all of these in order to do these. Right. 6 is kind of like what we just did, but it's already in 4 terms, so we're going to use grouping. Split it down the middle. What do the first 2 have in common? M squared. What would be left? Or m minus 1. And then what do the last 2 have in common? N. 1 positive n. What would be left? 4m minus 1. Rewrite your answers. M squared plus n and 4m minus 1. What would your final answer be? 4m minus 1. Okay. Last one. For number 7, we have m squared minus 9. Anyone remember how to factor that? Two terms, they're perfect squares. We're going to use our difference of squares. How do we do that? What will give you m squared? M times m. What times what will give us 9? 3 times 3. So our factors are m minus 3 and m plus 3. So what's our final answer? M minus 3. Right. I'm going to show you 2 things in Desmos, and then you will have time to practice. So 1, I'm going to show you one of these. So let's say I choose number 7. But instead of m, I have to use x. So x squared minus 9 and x plus 3. What's going to happen is when you go to put the whole thing in, you're going to get just a line, which is the line we found, m minus 3 or x minus 3, where your y-intercept is negative 3 and your slope is 1. So for all of them, double check them in Desmos, see if your line matches your answer, change the variable to x. So the other thing I'm going to show you in, let's see this for 1 second. On the page that says SOL practice, what's that last number? 1640. It'll ask for the factors, like this could be an SOL question. You're given something like this, and it asks which of these are the factors. Can you read this off to me?
4x minus 5, 5x minus 4 plus 5, and 5x plus 4.
Anytime it asks for factors of whatever, your answer choices has to go through your original at the x-intercept. And here there's only one that does that. So whatever the red line is, 4x plus 5, that would be your factor. You could also put this over each one and see which one overlaps the line that would be given. Right. For the remainder of class, you could be working on the following. More practice from today's notes. Khan Academy that from today, so that's due next week. Khan Academy that's due Friday. Be working on your SOL A6C, A7, A8D. You guys can work together. Let me know if you need my help. Have any questions? Make sure you're using this time wisely, though.